Hello everybody, I am Ben from Team Panic, and today we're going to be talking about rubber in combat robots, and more specifically rubberized filament in the 3D printing and making of ant weight or 150 gram combat robots. As you can see, this combat robot here is actually a reprint of one of my robots called Slightly Crude, but I've done this in TPU, just a kind of generic TPU. I think I got mine from Blue Printed, and I did this kind of as a bit of an experiment. I had the TPU set up on my machine, and TPU is one of those things where once you've got it set up, you might as well just keep printing with it because it's always a little bit difficult to get set up and get running. So I decided to run off a complete combat robot shell just to see what would happen, because a lot of the times when you're talking about protecting and putting up a good defense, a lot of people go for stiffness and hardness in the materials that they use. So I thought, let's see what happens when you go the other way and you go for that flexible type of shell and see what happens. And as you can see from this front wedge here, it actually held up remarkably well. There's one really big gouge over here, which is actually from a saw blade, and this damage came from a saw robot getting up on the top of Slightly Crude here, and I was pushing him round, and all the time he was kind of stuck with the saw blade digging in, and because that was sitting there for such a long time, there's that nice little nick in that, and I'm not sure exactly how well that's coming up on camera, but there is a good little nick there. There is another small-ish nick from a horizontal spinner here, and there's a couple of nicks down through the bottom down here in the wedge from a vertical spinner. But on the whole, this actually held up really well, and some of these vertical nicks, the weapon was strong enough to throw the entire robot up and over upside down. Thankfully I can drive inverted in this robot, but as you can see, these nicks down here are just that. They're just tiny little nicks. They're not a huge amount of damage, especially when we compare this shell to some of the previous shells, which are like this. So as you can see, these shells have got different types of protection on them. So as I said before, I have been using different techniques to try and harden the front wedge here to try and get some more protection on it. So this bottom one here is just a piece of aluminium which has been epoxied on, and then there has been epoxy applied around the edges as well to get a bit more stiffness and hardness out of these. These are actually PLA plastic, so they've held up relatively well, but even as you can see here, the weapons that we're talking about are putting huge gouges in both the aluminium and breaking through the layer of epoxy and starting to shatter the print. And then it's, as you can see, it's also doing the same thing at the back here and just doing that in a very bad way. And then this one over here, this one's actually covered in layers and layers of aluminium tape, and even with that it's still cutting through and doing all sorts of damage to these things. So yeah, the rubber robot has actually held up better than both of those. Now I know a lot of people who fight robots will tell you never ever to use PLA like I've done in those other combat robots, and these things hold up okay. They're not great, but every time I use those I do need to print a new shell for every fight or every match every month, and yeah, no shell gets used at more than one meet, whereas this guy printed really well, took a little bit of damage, but I am perfectly happy to just charge this battery and throw him right back into the arena. So kind of the point of making this video is to highlight this a little bit and show this off and see if other people out there can print some TPU robots and see how they go. But also, I got quite excited by this. I was very happy with the outcome of this robot and how little damage it sustained in terms of all of its fights. So I decided that I wanted to reprint my drum robot in TPU. However, I was thinking that the drum mounts in here need to be really strong in this direction so that they don't crush in on the drum while it's spinning. So I printed it in two halves, which looks like this. So we've got one half which holds the motors and the drum and the weapon motor, and then we've got the second half which is printed in TPU. I can scrunch that all around, do whatever I like with it. And that sits around the outside edge, just like this, and it needs to be glued on in some way, shape or form. So this was the idea, was to print this in two separate halves, glue it together. However, now that I'm holding both of these pieces in my hand, doing that gluing is going to be pretty difficult, I reckon. It's going to be a little bit interesting. This would provide quite a good lot of protection because of the rubberization that I was talking about before. It's just going to spring away from a hit. So what I'm thinking now, though, is I actually want to reprint this guy fully out of TPU. Do this entire thing out of TPU, and we'll see how we go from there. Let's see if we can get that printer set back up for TPU, print this shell off, and see if the drum will even spin in between two TPU uprights. Here it is, one fully TPU'd body shell. Now, this whole shell took me about 24 hours to print, just because the printer has to be going really slowly. I have to print these things at 7 millimeters per second, otherwise my extruder jams up, because it's just a regular extruder, it's not a flexible extruder. So it does have to go really slowly, otherwise things get really weird. However, what I kind of was worried about before is actually real. Like this, the drum that's in here kind of sort of spins if I hold my fingers around the edges like this. It gets a little bit of friction, but I mean, you could sand that out and it should be relatively okay, but only a minor amount of pressure is needed to just peel this open, and then the drum falls out, and that's that. So this is not a good idea. As you can see, this has got so much flex in it, just because it's not rigid enough. Like I'd need to add a lot more weight in rubberized plastic to actually have this thing hold rigid and not be able to do this back and forth. I might be able to get away with just putting a guard up in through here that ran all the way across. It's kind of like a half moon shape all the way along the front of the bot, but that would still add a considerable amount of weight, and I don't know how much it would stop this thing from flexing in and out like this. So this might be something that I return to in the future, rebuilding or building a different spinning robot that's designed to have the entire frame printed in rubber, because that is something that I'd like to do for a full robot at some point. But for the time being, it seems like this technique works really well for weaponless wedges, or at least for armament, because like these outside walls are a little squishy, but they would actually hold up pretty well against a hit. But holding weapons in place is a bad idea at this point in time. So there you go, that is this little quick experimentation on TPU. This was just done up to try and show this information off, I guess, to those of you out there who build 150 gram robots like these, and see if anybody else out there wants to pick this stuff up and start experimenting with it. Because like I said, I had quite a lot of strength out of this stuff, and this guy, I'm literally just going to charge the battery and throw him back in the arena in the next fight, because he is working absolutely beautifully, even after having taken a bunch of damage. Well, what should have been a bunch of damage, but with this rubberized wedge, it's all good. So yeah, like I said, just wanted to bring this to your attention and see what would happen if I tried to print a drum mount using the flexible filament, and that did not work. So there you go. I hope you guys have enjoyed this one, and I will see you in the next video.